Hello, welcome to this lecture video. I'm Teacher Mela and let's talk about measures of relative positions. So for our outline for the whole data management, so this is the same outline presented in the other videos. So we have data, measures of central tendency, measures of dispersion, and next is measures of relative position to be followed by probabilities and normal distribution, and we were going to end up with linear regression and correlation. So we are actually done with the three topics, and that measures of central tendency and dispersions were actually discussed also in the live streaming in the Facebook. Okay, so let us now consider measures of relative position. So the relative position is also called measures of locations, or maybe you are more familiar with fractiles. So it shows where the value stands in relation to other values in the data. So it is the extension of the median, and the most common measures of relative positions are quartiles, deciles, and percentiles. So let us talk about quartiles first. So for quartiles, this is dividing our distribution into four equal parts. And for us to determine the location, so what we are going to use is the formula. So let us consider the formula. So we have the symbol Q sub K, where K is equal to 1 to where K is equal to 1, 2, 3, 4, because of course this is dividing the distribution, or rather the set, into four equal parts. So K can be equal to 1, 2, 3, 4. And the general formula is Kn over 4. And N represents here the sample size. So this is our general formula for quartiles. And this is the formula that we use to determine the location of, if K is 1, that is the first quartile. If K is 2, it is the second quartile. If K is 3, that is the third quartile. And if K is equal to 4, that is the fourth quartile. Or it is also saying that if K is equal to 1, we are actually talking about, because Kn over 4 is 1/4 over n, which means we are talking about the 25% of the distribution. While for K is equal to 2, that is 2 over 4, 2n over 4, if we substitute it in the formula Kn over 4, this means that we are talking about 0.5, or the 50% of our distribution. So if it is K is equal to 3, so simply this is 3/4 all over n, or 0.75, or 75% of the distribution. And obviously for K Kn over 4, where K is equal to 4, that is the 100% of the distribution. But of course, you have to arrange. So it is a reminder that just like when you use the median, in locating for the middle term, you have to arrange your data from lowest to highest. Okay, so let us consider an example for our quartiles. So what is an example for quartile? So let's have, for instance, scores. Let's consider an example 1. So here, so given the following scores, let's say we have the following scores. So the perfect is 25. So we have the following scores. So the score of a student 1 is, I'll arrange it from lowest to highest. So for example, 15, 17, 18, 18, 19, 20, 23, and 25. So if we are computing for the first quartile, so that is q sub 1, 1 and over 4. So to count now for the number of distribution, so we have 1, 2, 3, 4, 5, 6, 7, 8. So let us add more. So let's, for instance, the score of the 9 and the 10 students is also 25, 25. So given the following scores, so what is the 1n over 4? So if we will substitute the value of n is equal to 10 because we have 10 data set here. It corresponds to 10 students. So 1 times 10 all over 4 is equal to 2.5, or we can actually round this off because of course we are going to consider the approximate value for q sub 1. So the location is, so this is approximately equal to, let's go back to our pencil, to the third data set. So what is the third data set? It is 18. What is the meaning of this data? So it means that the score, or rather 25% of the student obtained a score of 18 and below. So 25% of the students obtained a score of, so this is 25% of the students obtained a score of 18 and below. Or if we are going to look at the upper third quartile, so if it is an upper third quartile, it means that it is from the highest to lowest. So for q sub 1, this is the 25%. So this is the lower quartile. It is the 25% of the data arranged from lowest to highest. So for the third quartile, upper third quartile rather, so this means that 75, so let us write that. So another interpretation for this, so similar to this interpretation is that 75% of the students obtained a score of, in our data set, it is 18 and above. So it is, of course, because we have our data. So there are times that we are only going to use the 18, or rather above 18, simply because the next number is 19. But because we have our data and we can see in our data that the fourth score is 18, then we have to include 18 and above. But in case that you are just reported with the value of the 75% of the data, or rather you are just given the first quartile, which is equal to 3, and the third data is equal to 18. So you can just simply say that 25% of the students obtain a score of 18 and below, or 75% of the students obtained a score of 18 and slash or above. That is in case that we do not have our data set. Okay, next. So let us also consider Q sub let's consider, so we still have two datas here, right? So we have 25 and 25. So if we are going also to compute q sub 3, for example, so this is a 3n all over 4, where n is equal to 10 over 4. So this is the 7.5th term, or we round this off into 8 terms, and our eighth number is 25. So to interpret this, so the same with our previous example, so it means that 75% of the students obtained a score of a perfect score, because we know, we have the idea that the perfect score is 25. So it also depends now on this, it also depends now on our data set. So we can say that if we do not have the idea of the perfect score, then we might say that 75% of the students obtained a score of 25 and above. However, because 25 is the perfect score, then we can say that 75% of, or rather, 75% of the students, rather, so that's, let us rephrase that, because I'm referring to the upper 25%. So here, it is 75% of the students obtain 25 and below. While if we are talking about the 25%, so that is what I am referring to, the upper 25%, then the top 25% obtained a perfect score. So there's no need to say 25 and above anymore, because as we can see in the data, the 8th, the ninth, and the 10th student got a perfect scores in the test. So it actually depends on the data. So I repeat, the interpretation for the Q sub 3 is that 75% of the students obtained a score of 25 and below, and the upper 25% obtained a score of a perfect scores, which is 25. Okay, so let us also consider deciles. So how about for deciles? So for deciles, so this is dividing our distribution into 10 equal parts. So this is dividing the distributions into 10 equal parts. We use the symbol d sub k to represent now the measures of locations. And the formula is similar to our quartiles, except that our denominator, of course, is 10, because it is divided into 10 equal parts, where k is equal to 1 to 3 until, of course, equal to 10. And simply because it's, again, divided into 10 equal parts. So what is the percent when we are talking about k is equal to 1? So if we are referring to k is equal to 1, so that is 1n over 10, we are actually talking about the 10% of the distribution. If k is equal to 2, that is 2n over 10, we are talking also about the 20% of the distribution. For 3, it is the 30%, the 40% for 4, 50% for 5, 60% for k is equal to 6, 70% for k is equal to 7, 80% for k is equal to 8, and 90% for k is equal to 9. And of course, if k is equal to 10, then we are talking about the 100% of the distribution. So if we will again consider another example, so let's talk about age. So in this example, let us talk about age. For age,